Good afternoon, everyone. My name is Beatrice Crestani, and I also work here at the Physics Department of Padua. And I will talk today about our refractive index optical detector. We call it RIOD, for both monophysics and droplet-based microfluidics. So let's start from the motivation. In optofluidics, we combine photonics and microfluidics into lab-on-chip technologies, where the key parameter is the refractive index, which allows for label-free monitoring of both chemical reactions and molecular concentrations in real time. However, most of the existing platforms rely on complex optics, not only using lenses and optical fibers, but also requiring interferometers and nanostructures. Moreover, they need lasers, cameras, precise alignment, which limits the scalability and accessibility of these systems. Not only, but they also are not scalable to droplet microfluidics, which is instead widely used for biochemical assays. So to overcome these limitations, we developed RIOD, which is consistent of two flexible light pipes aligned with a capillary for the motion of the fluid inside. We have a LED and a photodiode, which are controlled by Arduino-based electronics mounted on this custom PCB. So the working principle is very easy, based on geometric optics. We have the capillary inside working as a lens-like optical element, where the transmitted light to the collecting light pipe depends on the refractive index of the fluid inside the capillary. So here we can see some numerical simulations showing the linear relationship between the output signal and the refractive index. So changing the refractive index is going to change the transmitted light, and so the voltage signals we get. These simulations match well with experiments. Experimentally, we are able to distinguish many fluids with a resolution reaching around 10 to the power minus 3 refractive index units, which is comparable with much more complex optics. We also adapted it to droplet microfluidics. We can see here a couple of examples. On the left, we have a train of sucrose dilutions in droplets. We are able to distinguish all the dilutions. And on the right, instead, we can see the monitoring in real time of an enzymatic reaction happening inside the droplets. And here, also, the motion of the droplet itself is determined by the sensor. So we trigger the motion of the droplets inside the capillary thanks to our RIOD. So this is all. And the key parameters is that RIOD is very simple, low cost, but it works very well for many applications. Thank you very much.
Thank you.